Here's our AP Stats 1.3 video, and we're looking at describing quantitative data with numbers. So what are different measures of center and spread we can use to analyze a distribution, and then when is it best to use each and why is our guiding question. So remember that the vocab and a copy of a similar outline to this is in your Schoology, as well as using your book can also help. Measures of center. We're going to talk about in general how the shape guides which one of these measures of center and which measures of spread to use. The mean is the average of the observations. We use X bar, the X with the hat over it, the line over it, to be the sample mean. We'll see that anything with a hat over it or a line over it will indicate the sample. Mu here is the population mean. It's a measure of center with uniform, symmetrical, and roughly symmetrical distributions. In that case, the mean equals the median if it's perfectly symmetrical. It does give us a lot of information if it is symmetrical, so we will prefer it to the median as we move forward and look at how to calculate a percent of a total distribution that's within a certain area due to the symmetry. It's not a good measure with skewness. So when we have any skewness, we're going to use the median. One key thing to picture with the mean is it's the point on which the curve would balance if it was placed on a triangle. So the outliers, if you have an outlier much bigger, it's pulling it to the right. So it is pulling that balance point to the right or making it much bigger. So one outlier can have a big effect on the mean. The median is the middle point. When I order all the numbers, it's the number that's in the middle when I order them from least to greatest. An outlier won't change the median. The largest number could get much bigger. The median would stay the same. The smallest number could get much smaller. The median would stay the same. The median you can picture as the equal areas point, the point that divides the curve into an equal amount of area on the left and the right. So let's look at what I'm talking about. Here we have the mean. It's the point where the curve would balance. Now the tail being further and further out would bring that triangle in the same direction. So it would skew right, means that mean gets brought up towards the right or much bigger. The median is the point where half the curve is on the right of it and half the curve is on the left. Because remember, that curve just represents data points, and each dot going vertically is a data point. So it would have the same number of dots on both sides of it, since it's the middle number. Sometimes you hear people say negative skew for skew left, because the mean gets reduced to a smaller number. You could hear positive skew. We'll look a lot as the year goes on at this normal curve and how that can help us learn more about data. So a perfectly symmetric distribution, the mean and the median would be equal. In a normal distribution, that also equals the mode here. If they're roughly symmetric, then they're close. The skew skews the mean in that direction. Let's look at an example of this. 2009, the minimum salary for Major League Baseball was $400,000. So a lot of players earn close to the league minimum of $400,000. Superstars earn much, much more than that. So they would skew the mean in which direction? Right, because they're going to make the average much bigger. So our average that year was $3.24 million, whereas the median was $1.15 million. Now the median tells us that a typical player earned about $1 million, a little over. The mean does not tell us a typical player because it's skewed by the players who earned a lot more than the league minimum. Here is an opportunity to look back on what we just went over about the mean and the median in terms of the balancing point, in terms of the equal areas point, and what does the skew of a distribution tell us in terms of the mean and the median. So pause right now. You can go back in the video if you need to review it, and then answer the multiple choice question. Then push play again to watch the rest and get the free response. So we talked in class about how the median is a better measure of center when we have skew. The same thing happens with standard deviation. We'll be going over this in our next class, but the standard deviation is the average distance from the mean of each data point. So how far are things, or how spread out are they on average from the mean? Because it's the average distance, that outlier will again make the standard deviation go up quite a bit. So if a skewed distribution occurs, we want the interquartile range. The interquartile range, remember, we chop up our data in fours. So the median chopped it in two. That gave me the number smaller than the median, or the first 50% of my data. The numbers bigger than the median, or the second 50% of my data. If I take that first 50% and find the median there, we call that Q1, or the first quartile, because that just chopped it up into 25%, the first 25% and the second 25% of my data. Then I look to the right of the median, to my second 50% of my data. Find the median of that second chunk of data, and that's Q3, my third quartile. So essentially what the interquartile range measures is the range of the middle half of my data. So how far spread out is the middle half of my data? That means that those outliers, which would be far to the right if they're outliers on the high side, or far to the bottom, don't play a part in it. So use IQR when there's skewness. So the IQR is the difference between Q3 and Q1, and we'll use that to define outliers. So an outlier, now we know, we'll take Q3 and add 1.5 times the IQR. That's the largest number that's not an outlier. We'll take Q1 and we'll subtract 1.5 times the IQR, which is what's represented by Q3 minus Q1, and that's the lowest number that's not an outlier. Here are the two ways we saw box plots. On the front of your packet for 1-3, you have a vertical one like this, where the maximum would be on top, the minimum on the bottom. Here's our 5-number summary: the minimum, Q1, the median, Q3, and then the max. If we have an outlier, it would be indicated with an asterisk, or I believe on a lot of your calculators we saw a small little square. On your calculator, it will look like this from left to right, where we have the minimum, Q1, the median, Q3, and the maximum, with a little square or an asterisk to indicate that we have an outlier. So here are some directions on making a box plot. These are also included in your outline in order to create it by hand. Remember, you can go to second y equals and go to stat plot to turn on the box plot, and use the one that shows outliers, that has the little asterisk or the little dots on the side of it, after you go to stat edit to enter your data. Standard deviation, we could represent it as S sub x, or we'll use another symbol to represent the standard deviation, sigma, which I'll go over in class with you. It's a measure of spread, and it's the average distance from the mean. So x sub I here represents an individual data point, subtracting it from x bar, or mean. And then you'd square those, because we're not concerned whether they're above or below the mean, just their the absolute value, how far they are from the mean. And we add them up and divide by n minus 1. Before we take the square root of that, we call it the variance. Once we take the square root, we call it the standard deviation. Because it's dependent upon the mean and it's the average distance from the mean, it also gets skewed by outliers. So if we have skew, we will use the IQR. So median and IQR are usually better than mean and standard deviation for describing a skewed distribution. Mean and standard deviation we can use for reasonably symmetric distribution. So here's your free response question. I would like you to use your calculator the way you did in class to make a box plot and a histogram to interpret this data set, including shape, outlier, center, and spread. Just double check that you have all 19 values when calculating it. So go to stat edit, enter these into L1, and then you want to go ahead and go to second y equals to turn stat plot on. Using L1, try both the box plot we did in class as well as the histogram. Remember, when you push graph to graph it, zoom 9, zoom stat will help you get a nice window. For your histogram, you may also want to go in and push window to make the bins a more reasonable size. So it's a good idea now to go back, review on the lesson. There's a 1.3 summary in your book that's a nice summary of what we went over, and then put this in your calculator and answer the free response.